Newark Public Schools. Mother's a janitor here. Probably snuck in while Mama was mopping floors. Dr. Gregory Sullivan holds Patricia's note card up, squints like examining trash, rips it in half, lets the pieces fall. 200 years, the greatest minds couldn't crack the Goldstein conjecture. But this black girl from the projects thinks we should stop everything and hear her brilliant insights. This is what happens when we lower standards. He grinds the paper under his shoe, turns his back completely. Patricia Ingram, 15, stands anyway, voice quiet. Sir, I believe it can be solved. The room erupts, laughter like thunder. 800 people, phones out recording, some pointing at her. Have you ever been called stupid by someone who never even gave you a chance? This is Princeton Public Math Night. Free event, open to the community. The university throws it every year for good publicity. Donors love it. Local papers cover it. Makes Princeton look accessible. Tonight, 3 professors present on impossible problems. Problems so hard they humiliate geniuses. Sullivan chose the Goldstein conjecture, a puzzle from 1823, 200 years old, over 60 published proofs. Every single one contained fatal errors. Most mathematicians now believe it simply cannot be solved with current tools. Sullivan has built his reputation on this belief. He spent 10 years trying to crack it in his 30s. Failed. Wrote a famous paper titled The Limits of Human Knowledge. Made his career on accepting defeat gracefully. He's been department chair for 15 years. Controls funding. Controls hiring. Controls who gets to call themselves a real mathematician. 800 people pack McCosh Hall tonight. Students, parents, high school kids hoping to impress admissions, wealthy donors, local press. 3 live stream cameras feeding to 50,000 viewers online. Patricia sits in the back row. She wasn't supposed to be here. Her mother, Diane Ingram, works the night shift. Cleaning crew, 6 in the evening until 2 in the morning. $43.50 per shift after taxes. Patricia often comes with her. Does homework in empty classrooms. Nobody notices a quiet black girl with a backpack in the corner. 3 months ago, she wandered into a calculus lecture. Just curious. Sat in back. The professor never asked for ID. She came back the next week. Then the next. She's attended 17 Princeton lectures this semester. Nobody ever stopped her. Tonight she saw the poster. Public Math Night. Free admission. She thought maybe, just maybe, she could ask a question during the open session. She wrote her question on a note card, waited in line with the other attendees, submitted it to the moderator. Sullivan read it, looked at her name, looked at her seat, looked at her clothes, and decided to make an example. Patricia is 15, sophomore at Newark Central High, takes the bus 90 minutes each way. Her school has no advanced math program, no calculus, no statistics. The newest textbook is from 2009. She teaches herself. Library books, YouTube videos, MIT OpenCourseWare on her phone at 3 in the morning. She discovered the Goldstein conjecture 6 months ago, read the original paper. It was written in German. She taught herself enough German to read it. The problem fascinated her, not because it was famous, because everyone was asking the wrong question. She's been working on it every night, filling notebooks, testing ideas. She thinks she found something. A way in, a door nobody else saw, but she's never told anyone. Who would believe her? Tonight, she thought maybe she could ask one question, get one piece of validation, just a crumb. Instead, Sullivan read her name aloud, mocked her background, ripped up her question, made 800 people laugh at her. Now she's standing. Everyone is staring, phones recording. Her mother was watching from the side door in her cleaning uniform, tears streaming down her face. Sullivan turns back to the podium, dismisses her with a hand wave. Security, please escort this young lady out. She's disrupting a private academic event. Two security guards start moving toward her row, but then a voice cuts through the room. Gregory, she submitted a question during open Q&A. You can't remove her for asking a question. Professor Raymond Clark, visiting scholar from Stanford, one of the panel guests, a black man in his 60s, one of only 3 black mathematics professors in the Ivy League. Sullivan's jaw tightens. Raymond, this isn't a question. This is a disruption. Clark stands, walks to the microphone, looks at Patricia. What's your name? Patricia's voice shakes. Patricia Ingram, sir. Miss Ingram, you said you believe the Goldstein conjecture can be solved. Why? The room goes quiet. Waiting. Sullivan interrupts. Raymond, we don't have time for this. She's a child. She doesn't understand what she's talking about. Clark doesn't break eye contact with Patricia. Miss Ingram, why do you believe it can be solved? Patricia takes a breath. And this is where everything changes. What would you say if you had one chance to prove you weren't stupid to 800 people who already decided you were? Patricia's voice is barely audible. Because everyone's been answering the wrong question for 200 years. Sullivan laughs, sharp, cutting. Oh, this should be good. Please, enlighten us. What question have Gauss and Euler and Riemann been answering wrong? Patricia doesn't sit down, doesn't look away. Goldstein didn't ask if prime numbers follow a pattern in polynomial sequences. He asked if we can prove that no pattern exists. Those are 2 completely different questions. The room murmurs. Some are confused. Some are interested, Doctor. James Mitchell, guest panelist from MIT, leans forward. Sullivan's smile vanishes. You're playing word games. That's not mathematics. It's not word games, sir. It's the foundation. Everyone's been trying to find the pattern. But Goldstein's original question was whether we can prove the pattern is impossible to find with current methods. And if we can prove that, then we know we need new methods. Clark nods slowly. Gregory, she's describing meta-mathematics, proof of unprovability. Sullivan's face reddens. She read the English translation and misunderstood it. The original German is very clear. Patricia's voice is steady now. I read the original German, sir, from the rare books room, 3rd floor, shelf M-43, handwritten, 1823. The word he used was unvorhersehbar, unpredictable, not non-existent. Dead silence. Sullivan stares at her. You read the original German manuscript. Yes, sir. I taught myself German to read it. Mitchell stands up. Wait, she's right about the translation. I've read the original too. The English version from 1962 changed the meaning slightly. Sullivan turns on Mitchell. James, don't encourage this. She's a high school student who wandered off the street. She's a high school student who taught herself German to read a 200-year-old mathematical paper. That's more than most of my grad students do. The room's energy shifts. People whispering, some nodding. Sullivan sees he's losing control. His face hardens. Fine. You're so brilliant, Miss Ingram. Prove it. Right now. Come up here. Explain your revolutionary insight to everyone. You have 10 minutes. Clark steps forward. Gregory, that's not fair. She's 15. She hasn't prepared a presentation. She came here to challenge 200 years of mathematics. Let her challenge it. 10 minutes. If she's right, I'll publicly apologize. But when she fails, she leaves. Permanently. And she writes a public letter apologizing for wasting everyone's time. Patricia's hands shake. This is a trap. She knows it. 10 minutes to explain months of work. In front of 800 people. Live streamed. Recorded. If she fails, she's not just wrong, she's the example. The cautionary tale. The diversity case who proved Sullivan right. Her mother's voice cuts through. Baby, you don't have to do this. Diane Ingram steps forward, still in her uniform, cleaning gloves tucked in her belt. Patricia looks at her mother. At Clark. At Sullivan's smug face. At 800 people waiting for her to fail. She walks toward the stage. I accept. The room erupts again, but different this time. Not laughter, anticipation. Phones up, recording, live stream viewers jumping from 50,000 to 80,000. Sullivan smiles, hands her a marker, points to the massive whiteboard. 10 minutes, starting now. A countdown appears on the screen behind her. 10:00. The clock starts. Can a 15-year-old girl with a marker and 10 minutes do what 2 centuries of geniuses could not? Patricia stands at the whiteboard, marker in hand. 800 people were staring. The countdown reads 9 minutes 45 seconds. Her hand shakes. She writes the first line. Letters, not numbers. The Goldstein conjecture. Original question. 1823. Can we prove that the distribution of prime numbers in polynomial sequences is fundamentally unpredictable? She turns to face the audience. Every attempt for 200 years tried to find the pattern, but Goldstein wasn't asking about the pattern. He was asking if we could prove no pattern exists that we can see with our current tools. 9 minutes 20 seconds. Sullivan crosses his arms. You're stalling. That's not mathematics. That's philosophy. Patricia doesn't respond to him. She writes again. Obstacle 1. The philosophical trap. If you spend 200 years looking for something that isn't there, you'll never find it. But you also can't prove it isn't there, unless you change what you're looking for. Dr. Mitchell sits forward. She's talking about Gödel's approach. Incompleteness theory. Patricia nods. Yes, sir. Kurt Gödel proved in 1931 that some things cannot be proven inside a system. You have to step outside the system. Goldstein's question is the same. We can't prove unpredictability from inside traditional number theory. We need a new framework. 8 minutes 50 seconds. The room quiets. People are listening now. Patricia draws a simple diagram. 2 circles, one labeled local behavior, one labeled long-term behavior. Obstacle 2, the density paradox. Prime gaps look random, but random doesn't mean structureless. It means the structure is too complex for our current tools to see. Every prior attempt used continuous mathematics, calculus, analysis, integration. She draws an arrow between the circles. But prime numbers are discrete, individual, separate. You can't use smooth, continuous tools to study discrete objects. That's like trying to count atoms with a ruler. 8 minutes, 10 seconds. A student in the 3rd row raises his hand. Sullivan nods at him. Thomas Ellis, senior, Sullivan's research assistant. Miss Ingram, that's a nice metaphor. But where's the actual mathematics? You're just describing the problem everyone already knows. Patricia looks at him, then back at the board. Obstacle 3. The false choice. Traditional analysis forces you to pick. Do you study local behavior or long-term behavior? Do you use discrete methods or continuous methods? But Goldstein's conjecture lives in the space between. 7 minutes, 30 seconds. She writes faster now. More confident. At the boundary between local and long-term, there's a transition point. A single mathematical moment where both exist simultaneously. That's not a weakness. That's the door. She draws a new symbol, a bridge between her 2 circles. I call this a dual space operator. It lets you analyze both discrete and continuous properties at the exact same instant. At the boundary. Mitchell stands up, pulls out his phone, starts calculating. Sullivan's jaw tightens. You can't just invent new operators. That's not how mathematics works. 7 minutes. Patricia turns to him. Sir, when Leibniz invented calculus, he invented new operators. When Fourier studied heat, he invented new transforms. Every breakthrough required inventing something new. You're not Leibniz. You're not Fourier. You're a child. Then challenge my mathematics, sir, not my age. The room reacts, whispers. Someone claps once, then stops. 6 minutes, 40 seconds. Thomas Ellis stands again. Dr. Sullivan, I think I see a problem. Look at her diagram. She's combining asymptotic behavior with local density. But those are fundamentally incompatible. That's a freshman mistake. Several people nod. Sullivan smiles. Miss Ingram, Mr. Ellis has a point. You've conflated two different mathematical domains. They can't be analyzed together. Patricia studies her board for 5 seconds. Doesn't speak. Then she circles a section. Mr. Ellis, you're right that asymptotic and local are different. But look closer. I'm not conflating them. I'm analyzing their boundary. 6 minutes. She draws a new line. At the transition point, there's one infinitely brief moment where a sequence is neither fully local nor fully asymptotic. It's both. Traditional math forces you to pick one. My operator captures that single instant. She writes a new expression, not an equation, a description. If you measure the gap pattern at position n, that's local. If you measure the trend as n approaches infinity, that's asymptotic. But at the exact boundary, for one mathematical instant, the local gap equals the long-term trend. That instant exists, and it's calculable. Mitchell looks up from his phone. Wait, she's describing a dual limit operator. I've never seen this application, but the boundary condition she's describing is mathematically valid. Sullivan stands, walks to the board, studies it. 5 minutes, 20 seconds. He points to her operator. This is speculation. You haven't proven this boundary exists. Not in 10 minutes, no, sir. But I can show why it must exist. She writes quickly. 3 lines of logic. Prime numbers are discrete. Sequences are discrete, but distributions are continuous functions. The only way a discrete object can have a continuous distribution is if there's a boundary where discrete becomes continuous. That boundary must exist, and my operator describes it. 5 minutes. Dr. Sarah Bennett, the third panelist, speaks for the first time. That's actually a compelling argument. She's using proof by necessity. Sullivan's face darkens. A framework is not a proof. She hasn't actually solved anything. 4 minutes, 40 seconds. Patricia sets down the marker, faces him directly. Sir, you're right. I haven't shown you the complete proof, but I've shown you something nobody has seen in 200 years. A door, a way forward, and if you give me more time, I can walk through it. The countdown hits 4 minutes, 30 seconds. Clark stands, addresses the room. I move that we allow Miss Ingram to present a complete proof. Not tonight, but give her 1 week. Let her prepare properly. Then bring her back. Let the panel evaluate it fully. Will they give a 15-year-old girl a second chance, or is this where her dream dies in front of 800 witnesses? Sullivan turns to Clark. His voice is ice cold. Raymond, you can't be serious. We don't run a charity here. I'm completely serious. She's demonstrated a novel approach. She deserves a fair evaluation. She's demonstrated nothing. She drew some circles and invented a fancy name. Any undergraduate could do that. Mitchell stands. Gregory, I've been doing number theory for 25 years. Her boundary operator concept is sound. At minimum, it's worth investigating. The room buzzes, students whispering, donors watching, cameras recording everything. Sullivan sees he's cornered. If he refuses now, he looks afraid, like he's blocking her because he knows she might be right. He forces a smile. Fine, 1 week. Miss Ingram, you'll present a complete proof, not a framework, not a philosophy lecture, a full, rigorous, verifiable proof of the Goldstein conjecture. Patricia's heart pounds. Thank you, sir. Don't thank me yet. There are conditions. He walks to the microphone, addresses the room like a prosecutor. 1. The proof must be complete. Every step shown. Every assumption was justified. No hand-waving. No appeals to future work. 2. She presents it here, in this hall, before an expanded panel of 5 judges, 2 from Princeton, 2 external experts, and 1 neutral chair. 3. If even one judge finds a logical flaw, the proof is rejected, and Miss Ingram agrees to never again claim she solved it. Clark interrupts. Gregory, that's excessive. Even published proofs get revised. These are the standards we hold for anyone claiming to solve a 200-year-old problem. Or do you think we should lower them just for her? The trap is obvious. Patricia sees it. Clark sees it. But there's no way out. Dean Margaret Foster steps forward. She's been watching from the side. Dr. Sullivan, I'll chair the panel, and I'll ensure the evaluation is fair. Sullivan's smile doesn't reach his eyes. Of course, Margaret. Completely fair. He turns back to Patricia. So, Miss Ingram, do you accept these terms? 1 week. Complete proof. 5 judges. 1 flaw, and you're done. Patricia looks at her mother. Diane's face is streaked with tears. She's shaking her head slightly. Don't do it, baby. Don't let them hurt you again. Patricia looks at Clark. He nods once, encouraging but honest. This will be brutal. She looks at the countdown clock, still frozen at 4 minutes 30 seconds. The moment she stopped explaining and started defending herself. I accept! The room erupts. Half the people think she's brave, half think she's delusional. Everyone thinks this will be spectacular to watch. Sullivan extends his hand. Patricia shakes it. His grip is crushing. He leans in, whispers so only she can hear. You just ended your mother's career too. When you fail, everyone will know the janitor's kid wasted Princeton's time. She'll be gone within a month. Patricia's hand trembles, but she doesn't let go. Doesn't look away. Dean Foster announces the date. Friday, 1 week from tonight, 7 p.m. Same location. We'll open it to the public again and live stream it. The moderator dismisses the crowd. People stand, talking, arguing, recording reaction videos. Within 20 minutes, the video clips are everywhere. Teen challenges Princeton professor on 200-year math problem. 15-year-old girl versus Ivy League mathematics. Janitor's daughter claims she solved the impossible. By midnight, the main clip has 500,000 views. Comments split 50-50. She's incredibly brave. She's incredibly stupid. This is what courage looks like. This is what arrogance looks like. I hope she destroys him. I hope he destroys her. The hashtag trends, Goldstein challenge, people taking sides, mathematics forums exploding with debate. Is this possible? Can a teenager actually do this? Most professional mathematicians say no, politely. They admire her courage, but the math doesn't lie. 200 years of failure means something. A few say maybe, very quietly, because if she's right and they dismissed her, they'll look foolish forever. Patricia gets home at 11 p.m. Their apartment is 40 minutes by bus from Princeton, 1 bedroom. She sleeps on the couch. Her mother sits beside her, holds her hand. Baby, you don't have to do this. We can move, find another job. You can go to a different school. Patricia shakes her head. Mama, if I don't do this, then every girl like me will keep getting treated like I got treated tonight. Someone has to show them we're not stupid. You're 15, Patricia. This isn't your job. Then whose job is it? Diane has no answer. Patricia opens her notebook. 7 days. 168 hours. She has half the proof done. The other half is still missing pieces. She starts writing. Somewhere across town, Sullivan sits in his office, smiling. He's already chosen his 2 external experts. Both are his former students. Both owe him their careers. The fix is in. Can Patricia complete a proof in 7 days that took 2 centuries to defeat, or is she walking into a rigged game she's already lost? Day 1. Monday morning. Patricia doesn't go to school. Her mind screams with equations. Her mother calls her sick, goes to work. Patricia has the apartment alone. She spreads 17 notebooks across the floor, 6 months of work, every dead end, every breakthrough. The core problem is clear. She needs to prove the boundary exists. The moment where discrete becomes continuous, where local becomes asymptotic. She has the framework, but frameworks don't win. Proof wins. She works until 3 a.m., sleep for 2 hours. Continues. Day 2. Tuesday. Maya Richardson shows up, her best friend, holding food. You look like death. Patricia barely looks up. I'm fine. When did you last eat? Patricia can't remember. Maya makes her eat, sits across from her. Explain it to me. Maya, you wouldn't understand. Then make me understand. Pretend I'm 5. Patricia sighs, but explaining it simply reveals gaps in her logic, places where she assumed things she hadn't proven. Maya can't check the math, but she can ask, how did you get from this step to that step? 3 times, Patricia realizes she doesn't have a good answer. 3 holes. She stays up until 5 a.m. fixing them. Day 3, Wednesday. Patricia goes to Princeton Library, needs the original Goldstein papers, including damaged sections. She uses her mother's employee ID for the rare books room. The librarian recognizes her from the video. You're that girl. The librarian smiles. 3rd floor. Take your time. Patricia photographs every page, margins, crossed out sections, faded parts. She notices something. Page 31. Goldstein crossed out a paragraph, heavily. She holds it to the light, barely makes out words underneath. Latin. 1 sentence. What cannot be proven can be demonstrated. Her heart stops. Goldstein knew, 200 years ago. The proof was impossible with his era's mathematics. He left a path for someone with better tools. Patricia runs home, rewrites her entire approach. Day 4, Thursday, halfway through. Patricia's proof is 60 pages. Growing. Professor Clark knocks on her door. They walk to a park. He hands her an envelope. The 2 external judges Sullivan picked. Patricia opens it. Dr. Harold Brennan, Dr. Elizabeth Marsh. They're both Sullivan's former students. Both got positions through his recommendations. Both have publicly opposed diversity initiatives. Patricia's stomach sinks. The panel is rigged. 3 votes against you before you start. You need perfect votes from Mitchell, Bennett, and Foster. 1 mistake and you lose. So I can't make mistakes. Nobody's perfect, Patricia. Even correct proofs have small errors. But Sullivan won't allow revision. 1 flaw and he rejects everything. So I already lost. No. But you need to understand what you're walking into. This isn't about mathematics. It's about Sullivan protecting his reputation. Clark stands. Make your proof perfect, not just correct. Perfect. He leaves. Patricia sits on the bench until dark. Day 5. Friday. 72 hours left. Patricia has slept 10 hours total all week. Her phone buzzes. Unknown number. Miss Ingram? Thomas Ellis, Dr. Sullivan wants to help you. He has his personal research notes on Goldstein, 30 years of work, no strings attached. Patricia knows this is poison, but what if there's something useful? She responds, Where? An hour later, Thomas meets her, hands her a USB drive. She goes home, plugs it in. 200 pages. Dense. Technical. Brilliant. She reads for 6 hours. Sullivan's approach is masterful. He got closer than anyone. But he hit the same wall everyone hits, the density paradox. Patricia follows his logic and slowly realizes this is the trap. His notes funnel thinking toward his approach. His approach leads to the standard failure point. If she follows his logic, she'll fail exactly like he did. She deletes the files, starts over from her own foundation. Day 6, Saturday, 24 hours left. Patricia's proof is 93 pages. She prints it, reads front to back, finds 2 weak points. Logic sound, but not airtight. She rewrites those sections, tighter, clearer, more verification. The proof grows to 112 pages. Her mother comes home, finds Patricia surrounded by paper, eyes red, hands shaking. "Baby, you need to sleep." "I can't. It's not done." "If you don't sleep, you can't think about tomorrow." Diane sits beside her, takes her hand. "When I was your age, I wanted to be a teacher. Got into Rutgers. But my mama got sick. Had to work. Couldn't afford school and medical bills, so I cleaned houses, then offices, then universities." Her voice cracks. "Smart doesn't matter if they decide you don't belong. I learned to be invisible, to accept what they said I was." She squeezes Patricia's hand. "But you didn't learn that. You said no. And baby, even if you're wrong about the math, you're right about that." Patricia cries. First time all week, then sleeps. 4 hours. Deep. Day 7, Sunday. Patricia wakes at noon. Proof printed. 112 pages. 3 copies bound. She tries to eat. Can't keep it down. Maya texts. "You got this," Clark calls. "Remember? Perfect." 3 p.m. She takes the bus. 90 minutes. Reads her proof one more time. 5 p.m. Arrives. The parking lot was packed. Over 1,000 people are trying to get in. Security turning people away. Someone recognizes her. That's her. People stare. Some encouraging. Some are hostile. All curious. She walks to the side entrance. Her mother's employee entrance. Security stops her. "You can't come through here." "I'm presenting tonight. Use the main entrance." Patricia walks around, waits in line. 30 minutes. Finally inside. Every seat filled. People standing. Cameras everywhere. 150,000 watching the live stream. She sees Sullivan at the judge's table. Smiling. Confident. She sees Clark in front. Nodding. She sees her mother in the back. Hands clasped. Praying. 6:45 p.m. 15 minutes. Patricia sits alone. Proof on her lap. She's done everything she can. Math is sound. Logic is airtight. But the game is rigged. 3 judges against her. She needs perfection. And nobody's perfect. Can a sleep-deprived 15-year-old with a 100-page proof defeat a system designed to make her fail? 7 p.m. Dean Foster opens the session. The room was packed beyond capacity, fire marshals watching nervously. "Welcome to this special evaluation. Miss Patricia Ingram will present her proof of the Goldstein conjecture. The panel of 5 will verify. Questions allowed throughout. Miss Ingram, you may begin." Patricia walks to the front, sets down her bound proof, distributes copies to each judge. Sullivan flips through his copy, doesn't read it, just counts pages. 112 pages. This should take a while. Patricia begins. Her voice was shaky at first, then steadier. She walks through the framework, the philosophical reframing. The 3 obstacles. The boundary concept. 30 minutes in, she introduces the dual space operator, shows why it must exist. Proves the boundary is real. Mitchell takes notes furiously. Bennett nods along. Foster listens carefully. The 2 external judges, Brennan and Marsh, sit with arms crossed, faces blank. 1 hour in, Patricia moves to the critical section, the recursion proof, where every prior attempt failed. She explains how prime gaps behave at the boundary, how local and asymptotic merge for one calculable instant. Sullivan interrupts. Miss Ingram, on page 67, you reference a theorem by Kowalski from 1998. Kowalski's work was on elliptic curves, not prime distributions. How do you justify using it here? Patricia freezes. This is the attack she feared. Sir, I'm not using Kowalski as direct proof. I'm using it as structural inspiration. On page 68, I rebuild the framework from prime axioms. It's a parallel construction. Mitchell checks page 68. She's right. It's analogous reasoning, not direct application. Sullivan's jaw tightens. It's a sloppy citation. Misleading. Foster intervenes. Gregory, the citation is clear. She labels it as analogous. Continue, Miss Ingram. Patricia continues, but her confidence is shaken. Sullivan found something to attack. What else will he find? 1 hour, 30 minutes. She reaches the convergence proof, the final piece, the part that proves the sequence reaches a finite limit. She explains the logic, step by step. Careful, precise. Brennan, one of Sullivan's picks, raises his hand. Miss Ingram, your convergence relies on lemma 9 on page 89, but I don't see lemma 9 anywhere in my copy. Patricia's blood goes cold. She flips to page 89. Blank. The page is there, but it's empty. No lemma 9. She checks her own copy. Same thing. Blank. She checks the third copy. Blank. Her heart stops. The print shop. When she printed the final version this morning, the printer jammed at page 89. She reprinted it. But somehow the file got corrupted. Lemma 9 is missing from all 3 copies. Sullivan smiles, leans back in his chair. Miss Ingram, without lemma 9, your entire convergence proof is unsupported. The logic fails. Do you have lemma 9 or not? Patricia stands frozen. 1,000 people watching. 150,000 online. The proof that took 7 days, that cost her sleep, sanity, everything, is missing its most critical piece. What do you do when your one chance to prove yourself is destroyed by a printer malfunction? Patricia stands at the whiteboard, staring at the blank page 89. Her hands shake. Sullivan's voice cuts through. Miss Ingram, do you have lemma 9 or not? I wrote it. I know I wrote it. The printer must have... The printer, of course. How convenient. The room murmurs, people whispering, some sympathetic, most skeptical. Thomas Ellis, sitting in the 3rd row, leans to another student, loud enough to hear. I knew it. She never had a real proof, just smoke and mirrors. Patricia's vision blurs. 7 days. Everything she had. Gone because of a corrupted file. Dean Foster speaks. Miss Ingram, can you reproduce lemma 9 now? Sullivan interrupts. Margaret, we can't allow her to write proofs during evaluation. Either she has it or she doesn't. This is exactly why we have standards. Gregory, a missing page due to technical error is different from not having the work. Is it? Or is this a convenient excuse when she realized her logic doesn't hold? Patricia's voice barely audible. I can prove it. Give me 20 minutes. I can write it on the board. Sullivan stands, addresses the room like a prosecutor. Ladies and gentlemen, what we're witnessing is the collapse of an unprepared student who overestimated her abilities. This is what happens when we encourage people beyond their competence, when we tell them feelings matter more than facts. He turns to Patricia. You claimed you solved a 200-year-old problem. You demanded we take you seriously. We gave you a week. We assembled a panel. We opened this to the public. And you show up with an incomplete proof blaming the printer. His voice rises. This is insulting. To mathematics. to this institution, to everyone who took you seriously. Patricia's mother stands up in the back. That's enough. She made a mistake. The file got corrupted. Give her a chance to fix it. Sullivan doesn't even look at her. Mrs. Ingram, with respect, this is an academic evaluation. We don't give do-overs because someone forgot their homework. Diane's voice shakes with rage. You don't respect me. You don't respect my daughter. You decided she was too stupid to matter before she wrote a single equation. I decided she was unprepared. And I was right. The room erupts, people shouting, some defending Patricia, some agreeing with Sullivan. Security moves toward the aisles. Patricia stands frozen, tears streaming down her face. Mitchell stands. Gregory, this is cruel. Give her the 20 minutes. If the lemma is sound, we continue. If not, we reject it. That's fair. Brennan shakes his head. Dr. Mitchell, we have standards for a reason. You can't write proofs during evaluation. The work should be complete beforehand. Marsh agrees. If we make exceptions here, we undermine the entire process. Foster looks torn. The panel is split. We need a decision. Sullivan sits down, folds his hands. I vote we end this now. The proof is incomplete. Miss Ingram fails the evaluation, and we move on. Patricia looks at the blank page, at Sullivan's smug face, at the 1,000 people waiting for her to collapse completely. She thinks about her mother, 30 years cleaning buildings, invisible, told she didn't matter. She thinks about every black girl who'll watch this video, who'll see someone like them try and fail publicly, who'll learn to keep their heads down. She thinks about Maya's question. How did you get from this step to that step? And she remembers. Lemma 9 wasn't the original proof. It was the revision, the elegant version. But there was an earlier version. Longer, messier, but it worked. She picks up the marker. 20 minutes. I'll reconstruct it. Sullivan laughs. You can't reconstruct a lemma you never had. Patricia turns to him, voice steady now, clear. Sir, I don't need 20 minutes, I need 10. She starts writing. The room goes silent. Can she rebuild in 10 minutes what took her 3 days to create the first time? The countdown clock appears on the screen. 10 minutes, 00 seconds. It starts. 9:59, 58, 57. Patricia writes, fast. Her hand doesn't shake anymore. She writes the lemma statement first. Lemma 9. A bounded recursive prime sequence with specific gap constraints converges to a finite limit. 9 minutes 30 seconds. She writes the proof structure. Proof by contradiction. Assume divergence. Show it violates the boundary condition. Therefore, convergence. Sullivan crosses his arms. Watches. Waiting for her to fail. 9 minutes. Patricia writes the first step. Assume the sequence diverges. Then for any large value m, there exists a position n where the gap exceeds m. 8 minutes 40 seconds. She writes faster. But the boundary condition states that at the transition point, local gap equals an asymptotic trend. If local exceeds m, then asymptotic must also exceed m. Thomas Ellis whispers to another student. She's just making this up as she goes. 8 minutes. Patricia doesn't hear him. Doesn't hear anything. Just the marker on the board. Just the logic unfolding. But the asymptotic trend is the average over all gaps. If one gap is arbitrarily large, the average becomes arbitrarily large. This means the sequence is unbounded. 7 minutes 30 seconds. She circles a section. Contradiction. We defined the sequence as bounded. Therefore, our assumption of divergence is false. The sequence must converge. 7 minutes. She steps back, stares at what she wrote. Something's wrong. The logic works, but it's not airtight. There's a gap. Mitchell sees it too. Leans forward. Miss Ingram, What if the large gap is balanced by many small gaps? The average could still be bounded. Patricia's heart sinks. He's right. Her proof has a hole. 6 minutes, 40 seconds. Sullivan smiles. And there it is. The logic fails. Miss Ingram, you've wasted enough of our time. Patricia stares at the board. Think, think. Then she remembers. Not her proof. Goldstein's hint. What cannot be proven can be demonstrated. She erases part of her work, starts over. Wait, different approach. 6 minutes. She writes new lines. Consider not individual gaps, but gap distribution density. Define density function D at position N. 5 minutes, 30 seconds. If sequence diverges, density becomes arbitrarily sparse. Gaps spread further apart. But the boundary condition requires density to stabilize at the transition point. 5 minutes. Mitchell nods slowly. She's switching from individual analysis to density analysis. That's stronger. Patricia keeps writing. Sparse density contradicts stable density. Therefore, divergence contradicts boundary existence. Since the boundary exists, the sequence must converge. 4 minutes, 20 seconds. Brennan interrupts. How do you know a boundary exists? You assumed it earlier but never proved it. Patricia doesn't stop writing. Proved it on page 43. Discrete objects with continuous distributions require a discrete to continuous boundary. Boundary existence is necessary, not assumed. 4 minutes. She writes the final line. Therefore, lemma 9 holds. QED. 3 minutes, 51 seconds remaining. She sets down the marker, breathing hard. Mitchell reads it carefully, checking each step, following the logic. 30 seconds of silence. Then he nods. It's different from what she originally described, but it works. Lemma 9 is proven. The room erupts, half cheering, half protesting. Sullivan stands. Let me see that. He walks to the board, studies it. His face darkens. He's looking for a flaw. Anything. He can't find one. He turns to Patricia, voice cold. This is a different proof than what you claim to have. You changed your approach mid-evaluation. Yes, sir. The original was more elegant. This one is more direct, but both are valid. Or you never had the original and improvised this when cornered. Patricia meets his eyes. Sir, does the logic hold or not? Sullivan doesn't answer, returns to his seat. Dean Foster speaks. The panel will deliberate. 30-minute recess. The judges leave the room. Patricia collapses into a chair. Her mother rushes to her, holds her. Baby, you did it. You actually did it. Patricia shakes her head. 3 judges already decided before I started. Mitchell and Bennett might vote yes. Foster is neutral, but Brennan, Marsh, and Sullivan will say no. I lose 3-2. 30 minutes feels like hours. Finally, the judges return. Foster stands. The panel has reviewed Miss Ingram's proof. We have reached a preliminary conclusion. However, there is significant disagreement. Sullivan stands before she can continue. I'll be direct. Miss Ingram's work is interesting, perhaps even a novel. But the Goldstein conjecture is too important to validate based on one presentation by an unproven student. I move to require external verification before accepting this as a solution. That process could take months. Until then, the conjecture remains unsolved. Clark stands from the audience. Gregory, you're changing the rules. You said if the logic holds, she succeeds. The logic holds. The logic is untested, unreviewed. One presentation is not sufficient for a 200-year-old problem. Mitchell interrupts. Actually, Gregory, I took the liberty during deliberation of sending Patricia's proof to 3 colleagues, Dr. Carter at MIT, Dr. Patel at Cambridge, Dr. Mueller in Berlin, all specialists in number theory. He pulls out his phone, projects the emails on screen. First email, Dr. Carter. This is extraordinary. The boundary operator is genuine innovation. Preliminary review shows no logical errors. Second email, Dr. Patel. If this holds under full scrutiny, this is Field's medal-level work. The approach is unconventional but sound. Third email, Dr. Mueller. I have verified the first 70 pages. No errors found. The reasoning is novel but rigorous. Who is this student? The room explodes. Students on their feet, cheering, shouting. Phones recording everything. Sullivan's face goes white. Those are preliminary, not full reviews. Patricia stands, walks to the front, faces Sullivan directly. Dr. Sullivan, I have a question for you. A direct question. And I'd like an honest answer in front of everyone here. She pauses. Have you read my entire proof? All 112 pages? Sullivan opens his mouth, closes it. I read the critical sections. That's not what I asked. Have you read all 112 pages? Yes or no? Silence. The entire room was waiting. Sullivan's voice is barely audible. No. Patricia's voice doesn't waver. Then how can you claim it's invalid? How can you demand external verification when you haven't verified it yourself? You decided I was wrong before I wrote a single equation. Because if I'm right, if a 15-year-old black girl from Newark solved something you couldn't, then maybe your standards aren't about excellence at all. Maybe they're about keeping people like me out. The room is absolutely silent. 1,000 people, 150,000 online. Nobody breathes. Dean Foster stands. Dr. Sullivan, do you have a mathematical objection to Miss Ingram's proof? Yes or no? Sullivan looks around the room. Every eye on him. Cameras recording. His reputation is on the line. He sits down slowly. No, I have no mathematical objection. Foster's voice rings clear. Then this panel accepts Miss Ingram's proof as valid pending full peer review. Miss Ingram, congratulations. You have solved the Goldstein conjecture. The room detonates. Pandemonium. Students rushing forward. Maya tackles Patricia in a hug. Clark openly crying. Diane screaming with joy. Patricia stands in the center of the chaos. Numb. She waited her whole life for this moment, and all she feels is tired. What happens when you prove everyone wrong but realize the fight is never really over? The celebration continues. Students mobbing Patricia, reporters pushing forward, camera flashes everywhere. Then Sullivan stands, walks toward the exit. No words, just leaves. 10 minutes later, Dean Foster receives an email on her phone. She reads it. Her face goes pale. She approaches Patricia, who's still surrounded by congratulations. Miss Ingram, I need to speak with you, privately. They move to a side room. Clark, Diane, and Maya follow. Foster shows her phone. I just received a formal letter from Dr. Sullivan. He's resigned, effective immediately. From the panel, from the department chair, from Princeton. Patricia's stomach drops. What? I didn't want that. I just wanted... There's more. Foster pulls up another document, reads aloud. To the Princeton University Ethics Board and Dean Margaret Foster. I am writing to formally acknowledge that I allowed personal bias to compromise my professional judgment in the evaluation of Miss Patricia Ingram. My conduct was unacceptable. I request my name be removed from all future symposium materials and that Miss Ingram receive a written apology from the department. She scrolls down, shows Patricia a second letter, addressed to her. Miss Ingram, I have spent my career believing that mathematical truth is the only truth that matters. Today you proved a theorem I could not. More importantly, you proved that my belief in meritocracy was a shield for prejudice. I failed you as a scholar and as a human being. You earned your place through excellence I refused to see. The field is better for your contribution. I am worse for my blindness. You owe me nothing. But I owe you everything. Dr. Gregory Sullivan. Patricia reads it twice, hands shaking. He didn't have to do this. Clark speaks quietly. No, but maybe that's the point. You didn't just solve an equation. You held up a mirror. Foster continues. There's one more thing. 3 major journals have already contacted us requesting first publication rights, including Annals of Mathematics, the most prestigious journal in the field. It's your choice which one. Patricia looks at her mother, at Maya, at Clark. She thinks about Sullivan's letter, about his resignation, about the cost of being right. I solved a problem that took 200 years, but the real problem, the one Sullivan couldn't solve, was admitting he was wrong. Maybe that's the harder proof. When you win, is it really a victory if someone else has to lose everything? 3 months later, Patricia's proof is published in Annals of Mathematics. Cover story. The Goldstein conjecture solved. CNN, BBC, NPR, Al Jazeera. A 15-year-old genius solves a 200-year math problem. Princeton offers her early admission. Full scholarship. $50,000 per year stipend. Youngest student in program history. MIT calls, Stanford calls, Cambridge calls, Oxford calls, all want her. Diane Ingram quits her cleaning job. Princeton hires her as community outreach coordinator. $45,000 per year. Benefits. Respect. Sullivan is gone. Nobody knows where. Some say he's teaching at a small college in Vermont. Others say he left academia entirely. But his letter remains. Posted online. 2 million views. People debating what it means to admit you were wrong. Patricia stands in her old high school, Newark Central, the place that told her advanced math was a waste of time. She's speaking to an auditorium of students, mostly black and brown kids. Kids like her. A girl in the back raises her hand. Miss Ingram, were you always sure you were right? Patricia smiles. No, I was terrified I was wrong, every single day. Then how did you keep going? Because being scared doesn't mean you're wrong. It just means you're doing something that matters. Another student. What if we're not smart like you? Patricia's voice softens. I'm not special. I just loved something enough to fight for it. You all have that in you. Find what you love. Then don't let anyone tell you you're not good enough to do it. She hands out books, mathematics textbooks, donated from her prize money. Every student gets one. A young black girl, maybe 10 years old, opens hers, starts reading, smiles. Patricia watches her, sees herself 5 years ago. Goldstein's conjecture took 200 years to solve. But some problems, like convincing the world that genius has no color, might take longer, unless we stop waiting and start proving. She writes on the board behind her. What's the next impossible problem? The students stare at it, thinking, wondering, believing maybe they could be the ones to solve it. Patricia smiles. Who's ready to prove everyone wrong? The room erupts, hands shooting up, voices shouting, me, I am. And somewhere in all that noise, the future begins. If this story moved you, share it. If you've ever been underestimated, comment below. Tell me your story. Because this isn't just Patricia's story. It's ours. And we're just getting started.
Sullivan resigned. Patricia got a scholarship. Everyone calls it victory, but you know what haunts me most about this story? Before Patricia wrote a single equation, Sullivan ripped her notes card, ground undershoe, said black girl from projects could understand what the greatest minds failed 200 years. He decided who gets called real mathematician 15 years. Patricia taught herself German, worked 6 months, 17 notebooks, final week slept 10 hours total. Sullivan finally admitted no objection, just resigned, wrote a letter. I allowed bias to compromise judgment. You proved my meritocracy belief was a shield for prejudice. He didn't apologize because he learned. He apologized because she forced him to see. Patricia had to be perfect under impossible pressure just to get a fair evaluation. Her mother cleaned buildings for 30 years, invisible. Patricia almost became invisible too. How many brilliant kids right now are being dismissed? Not because they're wrong, because they don't look like someone's idea of genius. Sullivan only changed after public humiliation, after Patricia proved him wrong in front of the world. The system wasn't built for fairness, built to keep certain people out. Share if called stupid by someone who never gave you a chance. Subscribe to Sage Stories for stories where brilliance wins despite barriers. Comment: who underestimated you? Patricia proved genius only requires one thing: refusing to believe you're not good enough. Their doubts don't define your limits, your courage does.